All right, let's spend some time here, lads in the back, talking about the matrix. No, not the Matrix. That's a movie. These are called matrices. So first of all, there's something called a dimension, right? And that's down here. This word dim, that is short for dimension. So this is how we size or how we categorize our matrices by how many rows they have,
XYZ.
by how many columns.
XYZ.
Okay? So it's a number by a number. It's how many rows. Rows go horizontally, right? So we count how many horizontal rows there are, and then we count how many vertical columns there are. And that number, right, there's two numbers there associated with this matrix, is its dimension. Okay, so the dimension of these matrices is how many rows it has by how many columns. Okay, like an X and a Y is the rows and the columns. So let's spend a minute talking about the dimensions. So looking at matrix A, and this is how we organize a matrix. Okay, we organize it into rows and we organize it into columns. Okay? So how many rows does matrix A have? Two rows. And how many columns does matrix A have? Three columns. So this would be a 2 by 3 matrix. 2 by 3. 2 rows and 3 columns. It's always row by columns. How many does it have horizontally? And how many does it have vertically? Okay, so how about B? What is B's dimension? It is also a 2 by 3 sized matrix. There are once again 2 rows and there are 3 columns. So that's a 2 by 3. Okay, so we're going to do that for the rest of these here and come up with their dimensions of each of these matrices, because that's the first step in doing any matrix problem. Okay, so what we need to know is if the dimensions are the same, like here we have a 2 by 2, and here we have a 3 by 3, and here we have a 2 by 2, right? These are a special group of matrices called square matrices. Okay, these are called a square matrix because their rows and their columns are the same, right? And that's true for a square, is that the length and the width are the same. So if your dimensions are the same, then you have yourself what's called a square matrix. Okay? Now the other thing we have to remember is in order to add or subtract, the matrices must be the equal dimension. So if your dimensions aren't the same, then you can't add or subtract them from each other, right? Because there will be elements of one matrix that don't have anything to combine with in the other matrix. Like look, for example, on matrix C and matrix D. Okay, I could add 3 to 2 because they're in the same position. I could add -6 and -4. They're in the same position, right? And I can continue doing this position by position, but now there's nothing to add these two over here. Okay, so you can't actually combine matrices unless they are the same size or they have the same dimension. So let's practice.
So Money got a PO.
Right.
Wait, what's the one guy like one NFL player just really bad?
Let's practice some adding. So let's add A to B. So these are a 2 by 3 matrix. So our answer is also going to be a 2 by 3 matrix. Okay? So in other words, we're going to have 6 terms or 6 elements to our answer. So what we do is we take the first position from A and we add it to the first position from B. So -1 plus -4 is -5, and it goes in that first position. Okay, and then we move over and we do the second row times the second row. 2 times 5 is, 2 plus 5 is 7, and it goes in the middle on the top. And then we move over and we do the next position. So we do this position by position all across your matrix. So negative 3 plus 6 is positive 3. Okay? We do this for all of our positions. So 3 plus negative 1 is positive 2. Right? And then we have, let's see, negative 2 plus negative 3 is negative 5. And then positive 1 plus 0 is 1. Okay, so addition is done position by position. Okay, you add them ones that are in the same spots. Add them in the same spots. Okay, so let's look at our second one, which is not only is it a subtraction, but it's also a multiplication. So we have matrix A. So there's matrix A. Now this says we have to subtract 2 times matrix B, which means I'm going to multiply all of my terms, every single term, every element in my matrix B by 2. Okay? Multiply them all by 2. So that's going to be a negative 8 and a 10 and a 12. A negative 2, a negative 6, and a 0. Okay, so I'm doubling all of the elements or all of my terms of my B matrix. And now I'm going to subtract it position by position. Okay, so subtraction. Minus a minus is always a plus. So negative 1 minus negative 8 is negative 1 plus 8, which is 7. 2 minus 10 is negative 3 minus 12, right? So we're doing all of this subtraction. My A terms minus my B terms. 3 minus minus 2 is a plus, so 3 plus 2 is 5. Negative 2 plus 6 is positive 4, and 1 minus 0 is 1. Okay, so we multiply all of your terms or all of your elements of your B matrix before you subtract it from your A matrix. Okay, so let's do that same thing for number 4. Okay, first let's multiply our C matrix by 3. So we're going to multiply all of these terms by 3. Everyone by 3. Okay, here's our 3 times matrix C plus matrix E. Okay, so hopefully you're noticing there's a problem here. Right, this is a 3 by 2 matrix, and our E is a 3 by 3 matrix. Okay, so are we able to add ones that are different sizes? No, so this is not possible because the dimension of C does not equal the dimension of E. Okay? The dimensions of your matrix have to be the same. They have to be the same size in order to be able to combine your terms. Okay? They have to be the same size, or it's not possible. Okay? So addition is kind of nice. It's position by position like you want it to be. Now let's talk about multiplication. Okay, with multiplication, right, we have to check their dimensions, and they can be square, right? Square matrices are okay to multiply together. 2 by 2s multiply by 3 by 3s. But here's the deal with your matrix multiplication. Okay, so we have row by column. Right, so this is for matrix A. We have some dimension of your matrix. The row by the column. And then we have multiplied by matrix B, which also has a row by the column, right? It also has a dimension.
That's hard.
Okay? Now, what we have to check before we do any matrix multiplication problem is, do the rows or do the columns of matrix A match up with the rows of column B? These two numbers in this position have to be equal. The numbers on the outside don't have to be equal. In fact, those must be equal to multiply. The outside one tells you the size or the dimension of your answer. The inner two numbers, when you look at their dimensions, have to be equal. The outer numbers tell you what size you're expecting the answer to be. Okay, so as we multiply these together, this will become hopefully more clear so that we can do this matrix multiplication. Now, this is some crazy stuff, matrix multiplication. It is not position by position. So if we're going to multiply matrix A by matrix C, first let's look at the dimensions. So A is a 3-row by 2-column matrix, right? That's matrix A. A 2 by 3, 2 rows by 3 columns, correct, excellent. A 2 by 3 rows by columns. C is a 3 by 2. So this is what we have to check first. Can we even multiply these together? Yes, we can. The columns of matrix A match up with the rows of matrix B. Okay? And we are going to expect the size of our matrix to be a 2 by 2. Okay, that's what we're going to expect. So we're going to have a 2 by 2 matrix as your answer, which means we should only have 4 numbers in your answer. Okay? So that's what we're expecting, is to have a 2 by 2 matrix which only has 4 terms. Okay, so now let's get to the craziness. Whenever we do matrix multiplication, it's the row of your left one times the column of your right. So we do it row by column. So we're going to take each element or each term in this row. We're going to multiply it by each individual term in that row. And then we add their terms together. We add their products together.
So you don't multiply it?
We multiply and add to get our one term. So let's go over this very, very slowly. So here we have our matrix. It's going to be a 2 by 2 matrix. Okay, and the reason why I'm making it so large is because we're going to have 6 terms in every spot when we multiply. Okay, so here goes our multiplication. -1 times +3. It's the first term of your row times the first term of your column. So -1 times +3 is -3. Plus the second term of your row times the second term of your column. 2 times 1 is 2. Plus the third term of your row times the third term of your column. -3 times -3 is +9. Okay? And now we move over and we do that same row times the next column. And we do it all over until every row has been multiplied by every column. Okay? So we do the first row, -1 times -6, which is +6. And then we do the second term, 2 times 2 is 4. Plus, we do the -3 times 0, which is 0. Okay, so we have got the top row multiplied by both of our columns. Now we move down to the second row, right? The bottom row. Now we're going to do this row times both of these columns also. Okay, and we do it term by term. So we have positive 3 times positive 3, which is 9, plus negative 2 times 1, which is negative 2, plus positive 1 times negative 3, which is negative 3. Okay, so this will be our last element. We have to do 3 times negative 6, which is negative 18, plus negative 2 times 2, which is negative 4, plus 1 times 0, which is 0. Okay, so now we've done all of our multiplication. So let's now add each of our terms together. Okay, negative 3 plus 2 plus 9 is positive 8. Okay. And then 6 plus 4 plus 0 is 10. 9 and negative 2 and negative 3 is positive 4. Negative 18, negative 4 is 0, is negative 22. Okay, so we have 4 terms in a 2 by 2 matrix, right? That's what we were expecting to have, is a 2 by 2. So we have 2 rows and 2 columns. We have 4 terms. Okay, I know, that's pretty crazy stuff, but that's the way we do matrix multiplication. Okay, so let's look at B. Look at B. What's the size of B? 2 row by 3 columns. And what's the size of D? It's a 2 by 2. So is it possible to multiply B by D? No, not possible. Okay? Because the columns of B do not match up with the rows of A. Right? They are not compatible to do. But what about C and D? Can we multiply those two together? So we sure can multiply C by D. And we're going to expect to have how many terms? 6 terms. Okay, our answer is going to be a 3 by 2 matrix, which is going to have 6 terms or 6 elements in it. Okay? So let's do our C times D. See if we can get this multiplication of row by column thing down. So let's see. First we do 3 times 2. 3 times 2 is 6. Plus negative 6 times 5 is negative 30. Okay? We multiply our terms and then we add them together. So now let's move over and do 3 minus 6 times minus 4
How'd you get negative 30?
and 1. So that first term is going to be negative 24. So then we move over and we have 3 times negative 4, which is minus 12, plus negative 6. This is negative 18. So now let's move down. We're going to do the second row. Second row times both of these columns. Okay, second row times both of those columns. So my terms are 12 and negative 2. And now I move down to my third row. And I do the third row times both of those columns. Okay, it's the row times each of these columns, term by term.
Is that box for number 4?
So that would be my answer for C times D, right? It's a 6 terms. There are 3 rows and there are 2 columns. Okay, so it's important to look at your size that we're expecting so that you don't get confused as to, have I done all of my rows times all of my columns? Okay, so yes, matrix multiplication is kind of crazy, but addition and subtraction, they have to have the same dimension.